Now that we've shown you how to collect the data for the lab, I want to show you how I want it placed in your lab notebook. As always, we want to have the title of the activity, and here's a diagram I want in there. The force of gravity is pulling down, which is, just as a reminder, force of gravity is always the mass times g. There's a normal force on the table or the board that's pushing up, and we're going to label that. Then we have the force of the LabQuest pulling. And since we're not accelerating, other than when we initially start, then you have to let up. So we want constant velocity. The force of the LabQuest will actually give us the force of friction because we're not accelerating. So even though we're moving, the forces are going to be balanced because we're not accelerating. Then we have a table, and again, as always, you can. There's a picture of the table of the entire notebook on the website that you can look at. The values I'm going to measure, this is where I talked about. I measured the 3 values. Now these are totally made up values, so don't think your values should look like this at all. I had a total mass of 1.5. Your mass of wood will not be that heavy, by the way. So that gave me a force in newtons of 14.7. So actually this should say measured also. No, actually this is computed. I measured this and I added that to the 1 to get my 1.5. Then I measured these values. My normal force I just computed by multiplying 9.8 times my 1.5, which I show down here. So this is how I computed my normal force. This is how I computed my average, which we all know how to do that. You just add the 3 numbers and divide by 3. This would be the average, then this would be a measured value. Now you can't find the percentage differences until you do the next part, so I can't go all the way across until I've done the whole table. So once I have all this table filled out, I want a static equation, an equation for the static friction, to where I take my Fs is my y value and my normal force is my x value. So this would be, if the way we normally do it, this would be in your L2 and this would be in your L1. Then I'll do the same thing. I'll still use my normal force as my x value, and I'll get my force kinetic. K is for kinetic, S is for static, my kinetic force, and I put that in. So now I get 2 equations. I just made these equations up, but you'll get actual equations. So it might look like my force of static friction is equal to 0.5 times my normal force. I had to mark that out. I wrote it down wrong the first time. So that means my mu, my coefficient of friction of the static force, is equal to 0.5. There's no labels on the coefficient of friction. You'll see the equation on your worksheets. We haven't really gone over. The purpose of this lab is to kind of introduce this equation, so I'll introduce it right now, that the force of the friction, if I just use F, is equal to the coefficient of friction times the normal force. That's always true. So in our case, we've got the force of friction. I used S for static. It's going to be the static coefficient of friction times the normal force. So once we get the slope of that line, we can find what the static coefficient of friction is. The same thing with the kinetic coefficient of the kinetic force of friction is going to be equal to the coefficient of friction for kinetic, the kinetic coefficient of friction times the normal force. So you can see my work. I made these pretend values. So then I went from row 1 and I actually took, since that should be true, that this coefficient, that my static force should equal my mu, my coefficient of friction, times my normal force. I went down here and I solved for that. That means my coefficient of friction is equal to the static force divided by the normal. So I divided that out, and in my made-up value, that went to 0.51, and I had a 2%. My made-up value for the next part didn't work so well. My equation, I said, came out to be 0.2 times the normal force, so my 0.2 is my kinetic coefficient of friction. From row 1, using the data that I made up and put in row 1, I take this 5 divided by the 14.7, that turns out to be 0.34, which is a pretty big difference from 0.2, so I got a big percentage error. And then you repeat the whole process. You do not have to show all your work on the second part unless you want to. If you can do it all in your calculator and you want to do that, that's fine. So all you'd have to have is fill in this table. The mass of block's the same. I just think it'd be easier to write it here so you can keep track of it. And write down what your static equation is, which means that's the equation for the static friction force. And this is the kinetic equation. And that's all there is to it. Good luck.